Look up at the night sky. It's a tapestry of twinkling lights. Each point of light is a star, a distant sun. We are about to embark on a journey through the universe. It is a journey to understand these stars. It is also a journey to understand ourselves. Our journey begins at home, on Earth. From here we can ponder the vastness of space. We can dream of distant worlds and imagine the secrets held within the stars. Let us set off on this cosmic adventure together. From space, Earth appears as a small, fragile sphere. It is a pale blue dot against the backdrop of the cosmos. This tiny planet is our home. It is the only place we know of that harbors life. Yet, as vast as Earth seems to us, it is a mere speck in the universe. Our sun, an average star, dwarfs our planet, and the sun is just one of billions of stars in the Milky Way galaxy. The Milky Way is a vast, spiral galaxy. It contains hundreds of billions of stars. If you could see it from afar, the Milky Way would look like a giant rotating pinwheel. Our sun sits on one of its spiral arms, far from the galactic center. Light from distant stars in the Milky Way takes thousands of years to reach us. When we look up at the Milky Way, we are seeing light from the distant past. This gives us a glimpse into the vast scales of time and space that make up the universe. The Milky Way is just one of billions of galaxies in the observable universe. Each galaxy is a vast collection of stars, gas, and dust. Some galaxies are spiral like ours. Others are elliptical or irregular in shape. The distances between galaxies are almost impossible to comprehend. Light from the most distant galaxies has taken billions of years to reach us. As we look deeper into space, we are looking further back in time. We are witnessing the universe as it was in its infancy. Section 5. Stellar nurseries, the birth of stars. Stars are born within vast clouds of gas and dust called nebulae. These nebulae are stellar nurseries. Gravity pulls the gas and dust together. As the cloud collapses, it heats up. Eventually, the core of the collapsing cloud becomes hot and dense enough to ignite nuclear fusion. Hydrogen atoms fuse together to form helium, releasing tremendous amounts of energy. A star is born. Section 6. A star's life. From fusion to giant. A star's life is a constant battle against gravity. The outward pressure from nuclear fusion balances the inward pull of gravity. This balance can last for millions or even billions of years. Over time, a star will consume its hydrogen fuel. As it runs low on fuel, the star begins to change. It expands and cools, becoming a red giant. Our sun will eventually become a red giant, engulfing the inner planets, including Earth. Section 7. Stellar death, white dwarfs, supernovae, and black holes. A star's fate depends on its mass. Smaller stars, like our sun, will eventually shed their outer layers. They leave behind a dense, hot core called a white dwarf. White dwarfs slowly cool and fade away over billions of years. Massive stars have a much more dramatic end. They explode violently as supernovae. These explosions are some of the most energetic events in the universe. Supernovae can outshine entire galaxies for a brief time. The remnants of a supernova can form a neutron star, an incredibly dense object. The most massive stars collapse under their own gravity to form black holes. Black holes are regions of space-time where gravity is so strong that nothing, not even light, can escape. Section 8. We are stardust, the cosmic connection. The life and death of stars have a profound impact on the universe. The heavy elements that make up our bodies, like carbon, oxygen, and iron, were forged in the cores of stars. These elements were scattered throughout space by supernova explosions. This means that we are all made of stardust. The atoms in our bodies were once part of stars that lived and died long ago. We are connected to the cosmos in a very real and fundamental way. Section 9. A universe of wonder. Our journey through the universe has taken us from our pale blue dot to the edge of the observable universe. We have witnessed the birth and death of stars. We have glimpsed the vast scales of time and space that make up the cosmos. The universe is a place of incredible beauty and wonder. It is a place of constant change and evolution. As we continue to explore the cosmos, we will undoubtedly make new discoveries that challenge our understanding of the universe and our place within it. Space holds many mysteries. Black holes are among the most fascinating. Imagine a place where gravity is king, so strong that nothing, not even light, can escape its pull. This is a black hole, a region of space-time cut off from the rest of the universe. Black holes are not empty spaces. They contain an incredible amount of matter packed into an unbelievably small area. This creates their extreme gravity. Think of the sun squeezed down to the size of a city. That's the kind of density we're talking about. These cosmic objects are invisible to our telescopes. We detect them by their effects on their surroundings. Stars swirl around them at incredible speeds. Gas and dust get pulled in, creating brilliant displays of light and energy. Black holes are both terrifying and awe-inspiring. They challenge our understanding of the universe, and they beckon us to explore the unknown. Stars are the cosmic furnaces of the universe. They burn brightly, fueled by nuclear fusion in their cores. But even stars have a lifespan. What happens when a star runs out of fuel? The answer, in some cases, is a black hole. When a massive star reaches the end of its life, it collapses under its own gravity. This collapse is catastrophic. The star's core implodes, squeezing matter into an infinitely small point. This creates a black hole. The more massive the star, the larger the black hole it can create. Some black holes are relatively small, only a few times the mass of our sun. Others are supermassive, millions or even billions of times heavier than the sun. The birth of a black hole is a violent event. It sends shockwaves across the cosmos, announcing the death of a star and the birth of something far stranger. At the heart of a black hole lies the singularity. This is the point of infinite density. All the matter that ever fell into the black hole is crushed together here. Our understanding of physics breaks down at the singularity. Surrounding the singularity is the event horizon. This is the boundary beyond which nothing can return. Once you cross the event horizon, gravity's pull is too strong to escape. Not even light can travel fast enough. Imagine the event horizon as a one-way membrane. You can fall into a black hole, but you can never come back out. Information about what falls in is lost forever to the outside universe. The event horizon is a point of no return. It marks the edge of a black hole's influence, a boundary between the known and the unknown. Once upon a time, in the vast expanse of the universe, there existed mysterious entities known as black holes. These black holes were not just cosmic vacuum cleaners, they also wove intricate patterns into the very fabric of space-time. One of the most enchanting phenomena was time dilation. As one ventured closer to a black hole, time itself seemed to slow down. This magical effect was due to the intense gravity warping the fabric of space-time. If you watched a clock falling into a black hole, you would see it tick slower and slower until it appeared to stop completely at the event horizon. Another curious effect was spaghettification. As an object fell into a black hole, the gravitational pull on its nearest side was much stronger than on its farthest side. This stretched the object like spaghetti. Imagine a brave spaceship approaching a black hole. The front of the ship experienced a much stronger gravitational pull than the back. The ship got stretched and elongated, eventually being torn apart. These extraordinary effects showcase the immense power of black holes. They distorted our familiar notions of space and time, reminding us that the universe is a much stranger place than we often imagine. And so, the tale of black holes continues to captivate and mystify us as we drift into dreams of the cosmos. Once upon a time, in the vast expanse of the universe, there were two kinds of black holes. Black holes come in different sizes. Stellar mass black holes are born from the collapse of individual stars. Supermassive black holes, however, are millions or billions of times more massive than our sun. These giants reside at the centers of most galaxies, including our own Milky Way. Sagittarius A** is the name of our galaxy's supermassive black hole. It's a sleeping giant, quietly influencing the orbits of stars nearby. While stellar mass black holes form from the death of single stars, the origin of supermassive black holes remains a mystery. Did they form from the collapse of giant gas clouds in the early universe, or did they grow over time by merging with other black holes? These are questions that astronomers are still trying to answer. Despite their differences in size, all black holes share the same fundamental properties. They are regions of extreme gravity with a point of no return at their center. They challenge our understanding of the universe and inspire us to unravel their secrets.
In the dark corners of the cosmos, where no wind stirs and silence stretches endlessly, there are nurseries. Not for children, but for stars. These places are called nebulae. Gigantic clouds of gas and dust spanning light years across. They drift, barely moving, glowing softly from the light of nearby stars. They look like brushstrokes in the void, painted in pinks, blues and violet mist. These are the cradles of light, where something incredible begins. A star is born slowly, not with a flash, but with a whisper. Gravity gathers particles, pulling atoms closer and closer over thousands, millions of years. In time, pressure builds, the center heats up, until suddenly the impossible happens. Fusion hydrogen atoms crash together, forming helium and releasing light. A star is born. And so light begins to shine, softly at first, then steadily, then fiercely. Across the universe, this dance has played out 1 trillion times. Each star, a tiny sun, a furnace of brilliance holding planets in its sway. Our sun is one such star. It burns calmly, turning hydrogen into warmth and light, keeping Earth alive with its steady rhythm. It's been doing this for 4.6 billion years, and it will continue for about 5 billion more. But not all stars are the same. Some are tiny and cool, red dwarfs that flicker gently for trillions of years. Some are enormous and blue. Blue giants so hot and bright they live fast and die young. And others, like our sun, shine with a golden glow, balanced and stable, each one a clock made of plasma ticking toward its destiny. But every star must one day fade. Some shrink quietly, they become white dwarfs, tiny dense cores glowing faintly like embers. Others grow first into red giants. Their outer layers swell and stretch, engulfing nearby planets. Their light turns red, and their surface cools like an old fire preparing to dim. Eventually they shed those outer layers, a final breath, leaving behind a glowing cloud, a planetary nebula. At the center, a white dwarf remains, a quiet memory of what once was. But the most massive stars end with a bang. When their fuel runs out, they collapse inward, then explode outward in a supernova. For a brief moment, they shine brighter than the galaxy around them. This explosion creates heavy elements: iron, nickel, gold, uranium, all the atoms that make up your bones, your blood, your thoughts, were forged in stars that lived and died billions of years ago. Yet, you are made of stardust. This is not poetry, it's chemistry, it's truth. The calcium in your teeth, the iron in your veins, the oxygen you breathe, all came from stars. And when you look up at the night sky, you are not just looking at lights, you are looking at your origins. You are part of this cosmic story, and the cycle continues. From the ashes of dead stars, new nebulae form. From nebula, new stars. From stars, new worlds. And from those worlds, perhaps life. It is a quiet rhythm, a slow heartbeat echoing across billions of years. Our sun, too, will one day change. In 5 billion years it will become a red giant. It will expand and Earth may no longer survive. Then the sun will release its outer shell, becoming a white dwarf, a glowing pearl in the sky. But long before that, our species may be gone or far away the sea, or watching from a different star. The stars remind us everything changes, everything ends, but endings create beginnings. The death of stars makes life possible. From destruction comes beauty, from darkness comes light. So tonight, as you close your eyes, remember, the light you see in the sky may have traveled thousands of years just to find you. Some stars you see have already died, but their light is still crossing space, still telling their story. You are made of that same light. Let that thought carry you into stillness, into wonder, into dreams. Now drift outward, beyond the planets you know, past Mars, past the asteroid belt, beyond the icy edge of Neptune, and into the deep cosmic sea. The stars begin to grow closer, not physically, but in your mind's eye. You're leaving the solar system and entering the realm of other worlds. They are called exoplanets, planets that orbit stars beyond our own. The first was discovered just a few decades ago. Today we know of more than 5,000. Some are similar to Earth, some are bigger than Jupiter, some are stranger than anything we imagined. Each one is a mystery, a secret wrapped in gravity and light, and we are listening. There's a planet called Kepler 186f. It's just a little larger than Earth, and it orbits in the Goldilocks zone, not too hot, not too cold. Liquid water could exist there, clouds could form, rain could fall. And beneath that rain, life may be moving, something breathing, something sensing, something looking back at the sky and wondering too. Then there's HD 189733b, a gas giant, deep blue in color, but don't let the color fool you. This is no peaceful sea. Its winds rage at over 5,000 miles per hour. Its rain, glass. Sharp side-blown shards of silicate crystals slashing sideways in a sky filled with storms. Imagine the sound, if sound could travel in space, but all we hear is silence. Next, we drift toward 55 Cancri, a super-Earth twice as large as our own and so rich in carbon that it may be composed largely of diamond, yet a planet made of crystal. Mountains glistening, grounds of sparkling black, a surface shimmering in starlight. Temperatures here can reach over 2,000 degrees Celsius. It completes a full orbit in just 18 hours. A year in less than a day. Brilliant, deadly, and dazzling. Some worlds orbit two stars, like the fictional world of Tatooine. You'd watch two suns rise in the morning, and two stars set at dusk. Your shadow would split, colors would shift, and day would always come in warm, layered light. Others orbit stars that have already died. They revolve in silence. No warmth, only the ghostly pull of gravity and memory. And then there are the loneliest worlds of all, rogue planets, wanderers. They orbit nothing, no star, no home. They drift through the dark interstellar void, alone, eternal night, no sunrise, no sunset. Just endless stars overhead, forever still. Imagine standing on one, your feet on frozen soil. No shadows, no sound, only your heartbeat and the stars. Could something live there? Not life as we know it, but something strange, slow, enduring, a kind of life that doesn't need light or warmth, only time. Our instruments are evolving. The James Webb Space Telescope is now peering into these alien skies. It can read the atmospheres of distant exoplanets. It searches for water vapor, carbon dioxide, and biosignatures. It sees light that has traveled for hundreds of years to reach us. It sees things no human eye ever could. A planet being born, a cloud drifting through another sky, a sun warming a distant ocean. One day we may find what we've been searching for, a world like Earth, a small blue planet orbiting a calm star, with clouds that move, with weather, with oceans. And maybe a heartbeat, maybe something lives there looking up right now, wondering if they are alone, just as we are. The search for exoplanets isn't just science, it's a kind of dreaming. We are not just explorers, we are storytellers. Every planet we find opens a door in the human mind. What would it feel like to stand there? What would you see? What would you become? Would your thoughts change beneath a different sky? Would time feel the same with two shadows on the ground? These worlds are more than statistics. They are mirrors reflecting our hopes, our questions, our longing to belong to something bigger. Someday we may send probes, then ships, then people. And one day a child may be born beneath a different sun, their first steps on alien soil, their lullabies sung under unfamiliar stars. And they will call it home. So tonight, as you close your eyes, know this. There are thousands of worlds beyond our own, silent, strange, beautiful, and they are waiting to be known. Perhaps we will go, perhaps we will listen, perhaps we will only dream, but that is enough.